Hello everybody, Brad the Guitologist is here with an exciting video. He has hired me, Sean Connery, to do this video for him, and we're going to do it together for him. Scotsmen, as Scotsmen and wonderful people of the world, we will do this video for Brad the Guitologist. Stay tuned for the box opening. Okay everyone, let's delve into the box now. Let's see what is inside. Let's take off the toppings and look underneath. We can see here we have certain things on the top. Bubble wraps and cardboard, which is good. Very nice. More bubble wrap on the bottom. Big bubble wraps here, which we will put all over our face later in private. And then underneath, we have something as it looks like an amplifier. And a personal letter to me. Letter to me, whoever I'm supposed to be. I will read it in private.
Hello, gentlemen. Thank you for that lovely introduction. Now let's take a look at the amplifier in question. This appears to be something very, very weird. Something I have not seen before in my long years on this planet we call Earth. But one thing I did want to point out initially here, just upon first inspection, is the fact that we don't have a whole lot of padding along the edges. It is very sparse in that regard, and I would just caution anyone who is doing this sort of thing in the future to apply more padding along the edges, especially on the corners where those tend to be dropped the most. Most damage tends to happen along the corners, and this corner in particular does not appear to have very much padding at all. We will extract the amplifier from its confinement and look at it upon the desk and see if there's anything amiss, anything wrong with it at all. So please stick around for that. Okay, that's quite enough of that. In all seriousness, this does look like a pretty cool little amplifier that we're going to delve into here. Just preliminarily, I can see a little bit of the covering has worn right here on this corner, and underneath I can see that this amp is made from a composite material, kind of like the stuff that you would see on old Dan Electros. So I would not be surprised if this was a Dan Electro. And there's also some wear over here on this corner with that material also exposed there. But the owner of this amp said in his note that the only thing he could find was that this might be a Marvel 25, that he had found an identical one, a nearly identical one that was logoed with Marvel 25. So we're going to do maybe a little research and try to solve the mystery on this for him. Look at the components, maybe that'll give us some clues. The handle right here, I feel like I have seen before. In fact, I know I have seen a handle like that before, with the grips and plastic. And a lot of times handles will really be a giveaway on amplifiers, in addition to coverings and materials and things like that. But I think on this one we might have to crack open and look at the inside to really get a clue at what it is. So stay tuned for that. Here's a better look at the back of the thing, and we're going to remove the packing material here. He did say that he packed the tubes separately, so I expect to see those in here. And I think that's them right there. Alright, so there those are. And it's always good to see some care taken in the packaging. And this packaging went pretty far up in there. And I might stand corrected on this thing. Look at that. This cabinet is actually plywood. And that's a birch plywood. Look at the baffle there, though. The baffle is what I was probably seeing on the front there. That's the composite material. that's similar to Danelectro, but Danelectro didn't do this very much, if at all. So I don't know. I'm still thinking that this might be a New Jersey company, East Coast maybe. I feel like I have also seen this paint scheme before as well. So I'm thinking New Jersey on this. This is just all that is written on this is AC/DC, volume on and off, microphone input, instrument inputs, and a serial number 6745. So let's take the back off this and see what else we can find out. All right, first though, let's take a look at the tubes that came along with this thing. We have what looks like an RCA 12AX7 here, which is pretty typical for what you would see in a series filament amplifier of this kind of era. Second, we have a 50C5, which is our power tube. Something there. The 50C5 is a Sylvania, made in the USA. I do not see any kind of... It's definitely made by Sylvania. You can tell that by that stamp right there. They always put USA, and had this kind of silvery color to their ink, to their inking on the tube designations. Sylvania's really good stuff. Okay, so there's the 50C5. Those have a tendency to be microphonic, so we will keep that in mind for later. Here's a 35W4 rectifier, and it is a GE. Definitely made by GE. You can always tell GE tubes because they usually had the tube designations were kind of in this segmented font. You see how the 3 is like in little segments and the 5 is in little segments, and they have USA underneath and some dots. So you can usually tell a genuine GE tube from that. Of course, it does say General Electric, but some of the General Electric labeled tubes were also not made by them. It's kind of rare, but this one is actually has a date code, 1962, the 26th week. So yeah, that 188 right there will give you the 188-4. That'll give you the factory in which it was made. I'm not sure exactly where that was. That might have been back east, and that might actually give us a clue also to where the amp might have been made, because it would stand to reason that they might source a tube from a nearby factory instead of a far away one. So that might be a clue right there. So we might look that up later if we get stumped. One other note before I remove this back door, it looks to me like the screws are definitely original. They're all these black flathead screws. These have a rounded top, but they are all, I'm sure, original to this amp. So that's one thing of note too. I don't think this thing was really messed with much and was probably played just a handful of times and then put in the back of someone's closet, it looks like to me. So let's get this back door off and see what we're looking at inside. Alright, here we are with this amp open, and the mystery really only deepens from here, and I'll show you why. Here's the speaker. The speaker clearly is marked 6207. That's the 7th week of 1962. The speaker model looks like it's SP600. And then we have an 1164 right there as our manufacturer code. The problem is 1164 is listed as an unknown, or is actually not listed. You can see here it goes from 1163 to 1165 and then to 1166, and there is no 1164. Moving along to the chassis now, and things get even weirder. Of course, we understand we have our 3 tubes here. Here's our code on our transformer. That is the output transformer right there. It is a code 1038-143. So that's 1961, the 43rd week. I think that's a 3 or an 8. Either way, 1038 is the manufacturer code on that one. and that is Captron Corporation out of Chicago. So that tells us this might be a Chicago amplifier. However, if we keep moving along, we will see some other conflicting sort of geography going on here. We have a 1081, 61, 44 on that, so that's the 44th week of 1961, and 1081 is Synchro Corporation out of Hicksville, Ohio. So there we have an Ohio component. We have a Chicago and an Ohio so far. Then we have these weird ass couplets up here, or couplets, however you want to say it. We have two big ones. These couplets like this, these are basically something that came along in the early 60s. You see them a lot in Gibson amplifiers. You've heard me refer to these in Gibson amplifiers as the tone-sucking network. Those are generally made by Sprague. However, these couplets have had, interestingly enough, very interestingly in fact, they have had the manufacturer codes blackened out. You see that little black mark right there? Someone has actually taken the time to black out both of the manufacturer codes on this couplet, presumably so they could hide from their competitors who was making this thing for them, and probably making their amps easier to build and a lot cheaper in the process by using these, and they didn't want their competitors to get the same leg up, so they actually went to the trouble to sit here and black out the manufacturer codes on their couplets. Now, I could be wrong, I suppose. I haven't looked it up yet. I could be wrong. Maybe that 710-516 is a reference to the manufacturer, but I don't think so, because see, this one right here and this one right here are certainly made by the same company, even though this one looks different. But you see the 711, 511, so that is a model for this particular couplet. That's a reference number for that model of couplet, and that's a reference number for this model. So someone has, yes indeed, they've blacked out the manufacturer code, which is just weird and interesting, and you can see all the little things that people were trying to do to get a leg up on the competition, and that right there I guess is one of them. But anyway, it's the 1961 51st week, so right at the end of 1961 on this. So these are unknown manufacturer. Interesting couplets. I've seen similar ones before, but mostly in hi-fi equipment and the like. Rarely do you see something like this in a guitar amp, and this is kind of throwing me for a loop because no manufacturer that I'm aware of used something quite like this. At least not Chicago manufacturers. Now, I'm a little more familiar probably with Chicago manufacturers than with some of the East Coast manufacturers, which can get kind of they can get kind of nebulous over there on the East Coast. There were quite a few of them. If anyone has any ideas who might have made this thing as just based on what we're seeing here, please chime in. The pot is it has a code of 140, which is Clarostat, and it's a 1960 first week of 1960. Clarostat is Brooklyn, New York. They had actually two factories, I think, one in Brooklyn and one in Dover, New Hampshire. So just the fact that they're using Clarostat rather than CTS pots tells me that it's probably an East Coast company, or something with more East Coast ties than Chicago. You see how this works? This is like we're just feeling out components here and seeing where things were made, because more times than not, manufacturers would not pay the additional shipping to have something shipped all the way from the Midwest over to the East Coast to build something on the East Coast. They would simply buy from an East Coast manufacturer. It would stand to reason. Unless the distribution was just that good from the other manufacturer that they were able to do that. Now, the fact that now usually transformers are the best indicator of where something was built, because transformers are the heaviest things to ship around. They're the heaviest things to move around the country. The fact that this transformer has a 1038 and is a Captron Corporation out of Chicago tells me it's quite possible this is a Chicago manufacturer. However, once again, we have so many other East Coast components, and it just doesn't ring true of any Chicago manufacturer I've ever seen.
particularly with those couplets like that. I don't recall having seen the like of it. So I'm a little bit stumped on this at the moment. Maybe if we look at the internet and we look at some comparables, that will give us some more clues. We can see that this back door is made of the same sort of material that you see a lot in Danelectros. I mean, almost identical. In fact, you can see the same sort of impressions in this material that you see in the stuff used by Danelectro, which tells me this could still be an East Coast company that made this, because Danelectro was in New Jersey, and it looks to me like they sourced this material from probably exactly the same place that Danelectro was getting their stuff, if in fact this wasn't made by Danelectro. So my chief suspects right now would be Danelectro, maybe Gregory. Of course, I've never seen these kinds of couplets in Gregory, but they were East Coast. Sano was a manufacturer there in New Jersey, I think, also, and there were some in New York too that are a bit more obscure. But yeah, right now I'm a bit stumped on the manufacturing side of this. So let's just move on to maybe plugging it in, seeing how it performs as is, and then seeing what we need to do to it. I know we're going to replace the cord with a 3-pronger. We're going to put a isolation transformer in it, change the caps. But the fact that it has these big couplets, which are kind of the precursors to integrated circuits, this made it really easy to wire this thing up. If you knew what the numbers stood for, you knew exactly which part of the amp it was supposed to go to, and basically you would just have a chart probably if you were sitting there wiring this thing up all day as a line laborer in the factory. You would just sit there and match the given numbers with a spot on a chart, and do that all day, and made it a hell of a lot easier to get just 2 of these components rather than individual components. So definitely, I'm sure this sped up their manufacturing process quite a bit. But again, I'm stumped. But this is going to be very difficult to do any kind of modifications to as a result of these couplets, because I'm going to have to trace these out. If we wanted to do anything to it, I'm going to have to make sure. Well, you see my dilemma, surely, because if I start trying to modify this, I'm going to have to clip, certain legs off of these couplets and do it that way, and that could get kind of messy. But we'll do our best here and see if it even needs anything. I'm not even sure if it does. I haven't even plugged it in the first time. So let's go ahead and plug it in the first time without doing anything to it, and just see what it is doing or not doing. Alright, so just to recap here, the speaker is of unknown origin, the transformer is Chicago, the capacitors are Synchro Corporation out of Hicksville, Ohio. We don't know on the couplets, although we do know they're 1962. The potentiometers are Clarostat from the East Coast, either Brooklyn or Dover. And the GE tube, it turns out, is from just down the road in Owensboro, Kentucky. Not in Schenectady, New York, which I would have expected if we had an East Coast company. So yeah, there's yet another loop thrown. Although, I will say the Owensboro code is by far 188-4 and 188-5 are supposedly by far the most the most widely seen. Schenectady is a little more rare, but that's just yet another little loop, because you would have expected, I suppose, to have that GE tube coming from Schenectady if you're building on the East Coast. But then again, what the hell do I know? Maybe Owensboro had better distribution. Although I did read somewhere that some of the tubes coming out of that were made in GE factories coming out of like Canada were labeled Owensboro. They didn't give Canada its own code. But they were labeled Owensboro, so Owensboro is basically taking responsibility for some of the ones coming out of Canada. So maybe it's that this tube came from Canada and not Owensboro. So I don't know. At any rate, just a weird one, and the mystery deepens. Alright, I got a speaker hooked up now, and I've got it plugged into the Variac, and we're just going to dial it up real slowly here and see what's going on. And alright, here it is dialed all the way up, and as you can see, got a lot of noise. I'm certain that's down to capacitors, electrolytics. Yeah, we're sounding very sick, very noisy. Electrolytics are probably to blame. That's actually the strings touching that metal piece down there. So we could be having some ground issues as well. That's sitting right down on the basement floor. So when this guitar string touches it, see there? Actually, let's try reversing that plug and see if that reduces noise at all. Alright, there it is with the plug reversed, and it definitely did actually reduce the noise some. A lot less noisy, but it does still sound really sick and just, you know, anemic. There's really nothing behind it. There's no balls, there's no anything. So we're gonna try to see if we can't make this thing actually sound like a real amplifier. Stick around. Alright, well, first things first, we're going to get rid of the power cord and we're going to add an isolation transformer. First thing we notice though about the tubes really is that what they add up to on the filament voltage is 50 plus 35 is 85 plus 12 on that, and you see that 9 pin right there bent over, so that does mean they're running that one in 12 at 12 volts. So we have about 97 volts being dropped by the filaments of the 3 tubes, and then we have an additional 47 ohm resistor right there coming off the switch to the filaments as well. So that is dissipating the rest, is dropping out the rest of the voltage and dissipating some heat. So depending on how this works out, what we might be able to do actually is either get rid of that resistor or change the value of that resistor. We may have to, depending on how this goes. But we have a new triad isolation transformer, an N68. Well, I say new, but it's still in the box. It's an old one. We're going to use this one. I've used these before in my videos, but we'll install this thing and see what we need to do about the series string, and see what kind of voltage we need to drop out of this. Alright, fastest way to do this is just to come in here and just start clipping things. We're gonna leave some of this lead on for our power cord because I don't know, we might use a terminal or something over here because we're gonna need a fuse on the secondary, so we'll leave a little bit of leads there. We'll come in here and clip this off. We're not gonna need any of this. So 1, 2, 3, 4 wires there, and then we come in here on this screw, or this nut rather. And this one's actually nice because it's not riveted to the chassis. A lot of times I have to break those off, but that one was real easy to get out of there. As we can see here, this was a synchro capacitor, as we said earlier. We had a red, blue, and a yellow wire at 40, 40, and 20 microfarads respectively, all of those at 150 volts. This 20 though is probably a bypass cap for the output tube, and 150 volts is probably over spec for that. So, we'll check that out. But that's kind of our baseline for what we'll shoot for. We may change this value as we go forward. We're also going to have to make an executive decision on where we're going to mount our transformer. And there's a couple different places we could do it. We could do it on the bottom of the chassis, or on the bottom of the cabinet rather, and then run leads up. The problem with that is These leads that are on here are not long enough, and we would have to splice every one of these and shrink tube them and all that stuff and run them up the side of the cabinet, and that's just not really the safest thing, to be quite honest. It's really safer to have everything at least behind where no one can just reach in and touch it. So our power transformer, actually we're going to mount to the back side, I think, of this front panel. Now that's going to mean we're going to have to put a couple of screws in order to accommodate it, but I think that's a better approach than mounting it to the side of the cabinet. We could also put it on the side of the cabinet over here and have screws coming from the outside holding it on. The problem with that is you would have to disconnect the leads or the screws every time you took the chassis out to service it, so that's not really a good thing. You really want all this coming together. Okie dokie, got the new transformer mounted, and got a new fuse and fuse holder in here mounted. Got everything wired up. Had to use another terminal over here for our secondary wires to give us something to mount everything to strap everything to. It turned out actually this 22 did need to be 160 volts, because that's not a bypass cap. That was, and if you'll recall, that's this guy down here, this yellow. That did need to be 150, 160 volts in this case, because that was going to the screen of the output tube and not a cathode bypass cap. If there is a cathode bypass cap, it's somewhere probably in this component. So everything's pretty much wired up. The screws don't look too bad. They're obviously there, but that it was always going to have to be something modified on this thing in order to get it up to operating condition and modern standards. So I think we're about ready to give this thing a test and fire it up slowly on the Variac, so let's go ahead and do that. And we're getting sound. Oh, that's much better. We're certainly getting some noise, but that doesn't have anything to do, I don't think, with... I think that has to do with more shielding and being out like this than anything. I could be wrong. Alright, she's dialed up to full power. We're going to check some of the voltages on these nodes. Let's see, we'll start with this guy. 115 volts right there. $110 volts right there. $95 volts right there. And let's see, what about the plates of the 12AX7? 26 volts on that first plate. Let's see if I can reach the second plate. It might be kind of hard. Let's see. Where's that wire going? That one's going right. Well, I can get it right there. 34 volts on the second plate of the 12AX7. It's kind of low for 12AX7. I'd like to see the voltage on that a little bit higher, but I don't know. That might be where that thing is meant to run in this design. We are getting some kind of crackling noises. at idle here. That's with the volume all the way down. And I don't know if we're going to be able to really mitigate that or not. I'll play around with it here and see if we can lessen that a little bit. We may or may not be able to, but let's play around with it here just for a minute or two and see what might be causing that issue. Alright, we're measuring the voltage potential between the common ground, where everything is hooked up that's recognized as a ground, and the actual chassis ground, which is going to the, the actual house ground. There's a difference there of about 14 volts. So we're going to have to do something to get that to 0, because we should have no potential between those 2 points, between the common ground and between the chassis ground. If you have potential between those 2 points, you're likely to get this sort of hum. Okay, obviously this thing is very noisy. I'm certain you can hear that. And this is turning out to be very much like another video that I just shot, where we showed the importance of good grounding. Well, this one is really no different, and I'll show you what I mean. Taking a gator clip, see the difference in noise there? The reason for that difference in noise is because we have a voltage potential between the common ground, where the I'll show you here, the common ground where our filter caps are grounded. I say grounded, they're really, that's the common. And these amplifiers, they elevate those above the chassis to keep you a little bit safer. And they separate them with a capacitor and resistor. This is a very similar amplifier, and we can see here there's a capacitor and a resistor right here separating this line, which is the chassis ground, and the rest of this over here, which ties to the line ground. So the line ground and the chassis ground, or if you prefer, the common ground and the chassis ground, are two different things. All right, I also determined this thing sounds a little bit fizzy and a little bit thin and a little bit weak. So I'm going to go through and maybe do a few modifications on this, but first I'm going to have to draw a schematic, and that's kind of easier said than done since I have absolutely no values on any components. So I'm going to have to measure all these values where I expect to see them. For instance, right now I'm measuring from the first grid to ground to get the grid leak resistor value, and I see here that it's 291K, so that can be up to 1 meg. And then we'll just kind of go through and draw it out as we go, and do the changes as we go as well, to try to maximize and optimize the output on this thing. Okay, at long last, I've gone through and pretty much completely rewired this thing. I've gotten rid of a lot of the connections on these couplets. In fact, some of the values of the resistors inside these couplets had drifted somewhat, and I think that was adversely affecting the tone. Furthermore, there were several instances in this amp where they were not really taking full advantage of the possible gain and the output that could come from the amp. So I've gone through step by step, and we'll kind of get an idea. Well, here, I started drawing this out and then just kind of gave up, but you'll kind of get an idea of some of the changes. I linked these first two inputs so they're the same, This one is not the same. For some reason, it has a 470K resistor, and I think this is one of the ones that has drifted up. I have not tested out this third input yet, but that's going to be suspect. I'll test that out momentarily. Added a 1 meg resistor in place of this 250K here, which improved the tone. Rebiased this stage. It was just going direct to ground. Now it's a 68K. Let's see, the 470K plate resistor here was replaced with a 100K, which did up the plate voltage quite a bit, and through to this stage. This was I think this one was a 0.01. I've made it a 0.022, and going through there were some other changes as well. I made both of the plate resistors 100K, and pretty much just did a complete revamp of this circuit. It's probably not what you would consider pretty. Looks pretty bodged together, but overall it's a much better amp, much more useful amp for sure. Well, I mean, it's even more useful, I'm sure, than it was originally. It sounds pretty darn good, actually, for what it is, and we will give it a test momentarily. Okay, to aid in our investigation here a little bit, the owner did say in his letter that he had discovered this amp, which is a Marvel badged Model 25. And this one is posted on reverb.com, and they want $400 for this, but you can see the striking similarity here. Same sort of cover scheme, different handle. This is more like a suitcase handle on this one. Different covering. This is more like a Tweety kind of a covering. If we scroll through the pictures here, this one has a badge on the front as well, which is Marvel labeled. And you can see the striking similarities just continue. And on the back especially, this is all pretty much the same. And we can see on a close-up the same paint scheme. So we've established that this amplifier that we have had a sister amplifier, which was labeled Marvel, and more specifically Marvel 25. Now if we look at some other Marvels, they kind of carry the same sort of trapezoidal shape here on the grill. Here's yet another one. The trapezoid is upside down on this one, and this looks like a little bit of an earlier one. And you can see here the paint scheme also that's used. Now this paint scheme with this kind of font, this sort of almost comic sort of a font, and also the stamped serial number right there is very similar. But you see this sort of thing very reminiscent of Premier amplifiers. You can see here this Premier has this trapezoidal shape as well. And Premier were also kind of famous for their strange paint schemes on their chassis, as also on their control panels. They had really colorful control panels. The parent company for Premier was Multivox, and these were all made in New York City, which jives with our sort of East Coast assumption on this thing. Here's another Premier. You can see again the trapezoidal front, and here's yet another one with a trapezoidal front, and another still with the trapezoidal front. So we've established that these Premier amplifiers had an affinity for this trapezoidal grill, and also this little clue. Here's another Marvel amplifier that looks much different, but this one is from this guy who posted this one in 2013. Gave some information on it. Now this one was sold in South Dakota, but that doesn't mean anything. This knob is definitely not original. Made in USA. This has an Oaktron speaker in it, which was made in Illinois, which, you know, if you followed that, would really throw you for a loop. But the biggest bit of information here is that this guy says this has a 7591 tube, and it was branded Multivox. So, bam, right there, that pretty much almost certainly ties the Marvel name with Multivox. Even though this is a completely different style, we know that Multivox was making Marvel amplifiers in New York City. And also, if you couple that with the fact that this trapezoidal shape grill is echoed so strongly in the Premier amplifiers, which were also made by Multivox, I think I can pretty much say with some level of certainty that this amp in question was made by Multivox in New York City.